Good afternoon, all of you. Welcome to this 3 days online FDP session on networking simulation. Today we have third day. So we will have a brief introduction of NetSim. Then we will have description of wireless sensor network and IoT. Then we will design and analyze a wireless sensor network scenario using NetSim GUI, and then one IoT scenario. The question answer will be discussed after the presentation. We will start with our presentation now. So we'll start with some brief introduction of NetSim. So first question here is why we require these kind of network simulator, or why we require NetSim software. So on this side of this slide, we can see there are some observation in networking domain is given, where we can see our existing network traffic will be 4 times in next year as per our use of mobiles, tablets and other handheld devices. Also we watch 2+ billion videos every day, which also constitutes heavy traffic on network. Further, more and more devices like mobiles and handheld devices are joining this network, forming a network of things. So these all observation constitutes these research areas like MANET, wireless sensor network, cognitive radio, LTE and LTE advanced, then IoT, Internet of Things. And 50% of all research papers in IEEE and NetSim refer a network simulator. So we require these network simulator for a research. So now introduction of NetSim. So NetSim is a popular tool for designing and validation of network and protocol, and hence it has a lot of relevance in protocol research and development. And in defense, it is used for simulating network-centric warfares. Then it has a wide range of technologies which is possible to simulate in NetSim are Internetworks, which is having LAN, WAN and wireless LAN. Then mobile ad-hoc network, that is MANET, WiMAX, cellular network, which consists of GSM and CDMA, cognitive radio, LTE and advanced, and wireless sensor network, IoT, and recently launched MANET, vehicle ad-hoc network. So the NetSim comes with 2 versions. One is academic and one is research, that is standard version. So in academic version, you can design your network through GUI, but in standard version, users are provided with C source code of the network protocols, which are implemented based on IEEE and IETF standards. So the purpose of giving this code is to enable users to edit the standard protocol according to their own implementation, and then they can link it with NetSim and analyze the performance of their newly designed protocol. So NetSim recently launched 9.1 version in August. So some feature has been added to the existing version. First is LTE advanced. It has been added with carrier aggregation and multi-antenna techniques such as SU MIMO and MU MIMO. Then relay nodes are there. Then in MATLAB interfacing, new application of creating and simulating real-world communication parameter and dynamic clustering in low-power wireless sensor network has been added to enhance the functioning of cluster heads in wireless sensor network scenario. In wireless network, a very popular and effective rate adaptation algorithm, Minster, has been added for an effective wireless communication in the network. Then in packet animation, detailed packet information has been added along with running the animation. Then a new technology, that is VANET, vehicular ad hoc network, has been added that can be simulated using a third-party software called SUMO, that is simulation of urban mobility, that is used for vehicular ad hoc network. So these are the new features added in NetSim. Now, NetSim has a huge number of customers varying from industries where it is used for network design and validation, to defense labs where it is used for network-centric warfare simulation. Then it is used in R&D labs for protocol development and new technology testing. Many PhD research papers are published by utilizing this tool, and NetSim also has an academic version to be used in network labs of undergraduate curriculum and advanced network lab. Now this is technology matrix of NetSim. So NetSim is divided into modules or component. So in standard version, users can make a selective choice while using NetSim. So this is a list of content of which a component and the corresponding IEEE and IETF standards refer during implementation of the protocols. So for illustration, component 1 consists of Internetworks, which is having LAN, WAN and wireless LAN, and Ethernet, and IEEE 802.11 AB, G and AC. And the component 1 is the base component. That is, all other components require component 1 to run all the components. Similarly, component 2 has legacy network, that is having Aloha, CSMA-CD, token ring, token bus, ATM, and all these legacy networks that we have. Then in component 3, we have BGP networks, that is border gateway protocols. And in component 4, we have advanced wireless network, that is MANET, mobile ad-hoc network, and WiMAX. And now WANET has also been added. Then component 5 having cellular network, GSM and CDMA. And component 6 is having IoT, Internet of Things, wireless sensor network, and ZigBee protocol. Then component 7 is having cognitive radio network, that is wireless radio array network. And component 8 is having LTE, long-term evolution, and LTE-A, that is long-term evolution advanced. So the NetSim is divided into these components only. This slide is also I'm repeating today because we have many queries regarding this. So on this slide, we have to try to answer the question asked by many people usually, that how this software is different from open source software available freely on internet like NS2 or NS3. So as we know, we have to write a lot of programming while using any open source tool for creating and simulating our network design. So users spend 80% of their time understanding the simulator and its language. And sometimes some people fight with its installation procedures that create hassle using it. So considering these difficulties, NetSim has been designed with its GUI feature along with custom codes editing, where we can design and analyze our network in GUI, and if we wish to change existing protocol or create our new protocol, that can be done using Microsoft Visual Studio 2010 version, where we can save our files in DLL extension, and further we can link it with NetSim GUI. So that is the main difference between open source tool and this NetSim software. Now these are some interfacing that NetSim is offering. So first is Wireshark. So Wireshark is a free and open source packet analyzer. It is used for network troubleshooting, analysis, and the communication protocol development. So in NetSim, instead of performing some mathematical calculation and providing the result to the user, it actually generates the packets and transmits it within the simulated network. Hence, Wireshark can be used inside NetSim to capture these packets at multiple node locations and perform further analysis. So in screenshot, we can see how the packets are being captured. And these are the graphs which can be generated inside the Wireshark software only. Now this is one of the interface with MATLAB, where we can use some functions given and related to network technologies by calling those functions in programming using Visual Studio. So we have to write this function inside our program and we can call them. And when we save those DLLs and link it with NetSim, we can use MATLAB functionalities. And this is Network Emulator, that is an add-on module which enables you to run live application in real time with various network conditions like error, delay, and loss. So in the screenshot, we can understand a scenario where we have created an emulated network where we are sending a video traffic from a real emulation PC client to other client. Where we can see in the output, we are getting our video with some distortion. That is due to delay and losses we face in the network during packet transfer. So these kind of real application can be used to analyze in emulation module. Its application are, it can be used for network design and validation of military radios, SCADA, metro rails, and for performance testing of new applications and protocols. And there are some benefits of network emulator. It can emulate a wide range of technologies like switching, routing, MANETs, cognitive radio network, 4G LTE, and ZigBee networks. It is a cost-effective alternative to hardware emulators as it's purely virtual. So it can be used to analyze without any complicated configuration that require in hardware emulators. So this is about the brief of NetSim software for those who have not attended on the today's session. So I just given them brief. Now we go to our core topic today, that is wireless sensor network. So wireless sensor network works on IEEE 802.15.4 standard, and this LRWPAN is low data rate wireless personal area network, which is widely used because it has sensing capabilities that is position independent, which means it can be deployed where humans can't reach due to non-living or toxic conditions for humans. Sensors are of very low cost and can be randomly placed in the sensor coverage area. So approximately 10-meter coverage range with a transfer rate of 250 kbps is there. Collision avoidance technique is used in CSMA CA, and is the frequency in between it works. And these are some applications where wireless sensor network can be used. It can be used for patient monitoring, that is in healthcare division, where they can offer wearable devices and implantable device in the human body, which can help in monitoring the patient. Then utilities of electricity grid, it is smart meters are been designed to give the current update of the meters. Then water principles, then remote monitoring, in which area monitoring is there. So wireless sensor network can be deployed in a region where intrusion monitoring is required, like detecting intrusion of enemies on border areas. And for forest detection, and I have an example of forest detection, as we've heard some few months ago, that news of fire in Uttarakhand spreading in forest areas, where it took many days to took over that fire by deploying many people from departments and army by using various techniques for overcoming this situation. So these kind of sensor would be deployed in those areas for monitoring. We can identify such situation within a frame of time in which it can be easily managed and it doesn't spread to other areas and create such panic in that situation. It can also be used for battlefield surveillance in warfare scenario to monitor the situation and send proper support to the soldiers on time. Then structural monitoring, industrial machine monitoring, these are the applications that sensors have. Then these are the devices which we use in wireless sensor network. So WSN has mainly two types of devices. One is FFD and other is RFD. FFD is full functional device. So as the name suggests, it has the full functionality. That is, it senses the agent, it routes the packets, initialize the network, which act as a PAN coordinator, and communicate with another RFD or FFD. Then RFD is reduced functional device. As the name suggests, it has some reduced functionality that it can only sense the agent and can communicate with FFD only. So these two types of devices we use in WSN. Then sync node, we have sync node is the principal controller in WSN, and only one sync node is used to receive data from sensors via a single agent used in the network. So it can work on beacon mode or without beacon mode. So when it uses beacon mode, it uses slotted CSMA-CA algorithm for transmitting packets. Otherwise, it uses unslotted CSMA-CA. Now agent. Agent receives the packet from sensors when it comes in the range of sensitivity, and the agent mobility can be modeled by random walk and random waypoint by its velocity that can also be configured. Then wireless sensor network has the spatially distributed sensors to monitor physically or environmental conditions like temperature, sound, pressure, which further pass their data to a main location, that is sync node, through a network, and that can further be stored through a other location, that is on cloud or any host located there. This is the scenario of deployment of sensors and sync node in wireless sensor network, where sensor will sense the fire object and send the data to sync node. This is about scenario in wireless sensor network, which are of two types. First is star topology, in which PAN coordinator, or we can say it is FFD, is centrally connected to other FFDs and RFDs in the network. Then second is peer-to-peer topology, where PAN coordinator, or we can say FFD, is connected to other FFDs and RFD in the network in peer-to-peer manner. You can see in the figure also. And these are the operational modes of wireless sensor network, where first hierarchy is IEEE 802.15.4 MAC standard that is implemented in wireless sensor network, that works on two modes, that is beacon enabled mode and non-beacon enabled. And beacon mode can further be divided into other parts in super frame. Then super frame can further divide into contention access period and contention free period. Then this can result into slotted CSMA-CA, and then non-beacon enabled, it is unslotted CSMA itself. So this is about operational modes, and this is the very important power model matrix that we require in wireless sensor network. So this is the screenshot of sensor properties we have. So that is the power features, where we can define the power source, either it is battery or mainline. Then energy harvesting is on or not, because power decreases as the sensor work in our network. So we require this energy harvesting to save our power. Then recharging current, initial energy, transmitting current, ideal mode current, voltage, receiving current, sleep mode current, and this is sensor range and intervals. And in the result also we have power model matrix. So we can see our energy consumption of the sensors, their ideal energy, sleep energy, and total energy consumed. So in sensors, the sync node transfer the packet, gets the packet through clusters. So some cluster heads are made. So from each cluster, one sensor is elected as cluster head based on remaining energy. Because sensor energy decreases, so it chooses the higher energy sensor. So it collects data from surrounding sensor in that cluster and passes that data to the sync node. And there is an LEACH hierarchy of cluster heads where the cluster heads keep changing according to their energy. So the LEACH is low energy adaptive clustering hierarchy. You must have known about this. Then it is a MAC protocol and a cross-layer protocol which works here. So I'll show you an example of LEACH protocol, how it is being implemented in wireless sensor network. So we have to get a leach.c file, and we have these functions, these four functions: check destination, get next hop, assign cluster head, and identify cluster. So these functions are made as per their names and these functionalities. That at check destination, this function is used to check whether the device ID is same as the destination ID. And get next hop is used to forward the packet from the current cluster head to the next cluster head. Then assign cluster head, it dynamically assign cluster head based on their sensor remaining energy. Then identify cluster, it is used to identify the cluster of a sensor. And this is the example of shown of LEACH protocol. I'll show you in the software. So before we go to the IoT part, we just see how we can work on the software using wireless sensor network. So first we simulate wireless sensor network, then we go to the IoT part. So for simulation, we have started the software, and in first part of simulation, we can go, and then in new part, there are different technologies given here. Whichever technology you want, you can select and design your network accordingly. So here we have to select wireless sensor network. So as you select wireless sensor network, it asks about the side length, and the side length should be an integral multiple of 50. That is 50 to 100 up to 1000. Then sensor placement strategy is there. Either it can be uniform or it can be random. So if you select uniform, you have to select the number of sensors in the multiple of 1, 4, 9, 16. Then if you select the random placement, it will place in the random manner. Or you can select the click and drop method also, so that you can click and drop the sensor according to your requirement. So I'm just selecting the 50 side length and 16 number of sensors, and I click on OK. You can see there are 16 sensors placed in our workplace. So here we can select the wireless sensor sync and the wireless sensor agent, and all the devices are disabled, as we have 3 devices required here. So we can see the properties of the sensor first. So as we can see, the device property have these layers, and first property is having global property, that is the sensor name, its location, its mobility model. 3 types: random walk, waypoint, and group mobility. Okay, so currently it is static. We can give them the velocity. So first we are simulating in static mode. In transport layer, UDP protocol is by default selected, and these parameters I have shown you that this can be studied by this information tab. You can click on this information tab and see what the parameters are. Then in network layer, the routing protocol is there. So by default DSR is selected. You can change it to AODV, ZRP and OLSR. Acknowledgement type is given there, either it is link layer or network layer. Then interface ZigBee, that is having the layer to layer information. So in network layer we have IPv4 protocol. In IP address we can assign subnet mask, default gateway, retry limit, retry interval. Then in data link layer we can define the acknowledgement requests, enable or disable, minimum back off, maximum back off. Then in physical layer, some properties are set as default, is modulation techniques and protocol, that is it works on this protocol only, so it has been assigned as static. You can define these variable properties. CCA mode you can define, carrier sense, energy detection, and carrier sense with energy detection. Then receiver sensitivity, ED threshold, transmitted power, and that power model information I have shown in the presentation, that power source, energy harvesting, recharging current, all these features, and this sensor range and interval. That is the information of sensors given here. Okay. This is about agent. Okay, agent has a mobility model and the global properties. And now sync node properties. So here device name is given there, location is given there, application layer is defined outside. So transport layer is given there, by default is UDP. Network layer protocol is defined. Interface ZigBee, network layer parameters, IP address and subnet mask. Then in data link layer, you can enable the beacon mode. Okay, you can disable and enable and beacon mode. So we are just disabling it right now, and you can set the maximum back off and minimum back off. In physical layer, these parameters as the sensors have. So when we enable this beacon mode, we have to set the super frame order and beacon order. Then if you enable the beacon mode, we have to change these parameters. So currently it is same, so we can modify it, either we can increase or decrease and see how it result our work. Currently we disabled it and see what our result is. So packet trace, event trace and dynamic matrix can be defined. So packet trace have the information of the packets, so we just click on OK. And event trace have the information of events. Then dynamic matrix have some graphs of link matrix and congestion window. So we choose plot graph after simulation. So now we run the simulation. So this is our overall network matrix, having simulation timing, packet transmitted, error, collided, bytes transmitted. You can click on this and study about this also, their definitions and their formulas what have been defined. Then these are the common matrices that we have in all the simulations, and these are some technology specific matrices, that is IEEE 802.154 matrices, that we have the device, all the devices enabled here, right? Sensors, their packet transmitted, packet received, acknowledgement transmitted, acknowledgement received, CCA attempt, successful CCA, failed CCA, back of time, average back of time, then beacon transmitted, beacon received, beacon forwarded. So we have disabled the beacon mode, it is 0. So beacon timing. So all this is about the devices and sensor matrices, their agent ID, the agent is same, their location and timing. Then power model matrix have the energy consumption according to the devices. So transmission energy consumed, receive energy consumed, ideal energy consumed, and sleep energy consumed. So sensors can be in these 4 forms. Either they can go into sleep, they are ideal, they are receiving energy, or they are transmitting. So on all the 4 parameters we have the energy parameters, and this is total energy consumed. This is a link throughput graph that we have defined in dynamic matrix, and in packet animation we can see how the sensors send the data to sync node by running this animation. It sends the RREQ and RRP reply, and here we can see the source and destination, packet info, and the status, either it has been successfully sent or it has been errored, and simulation timing running. So we can see either it is success or it is changing to error where it is being collided. We can increase or decrease the animation speed to see the faster animation. So here we have not defined any cluster head because it is running through the normal DSR protocol. So when we implement the LEACH protocol, it will define some cluster heads in between them that we have to define in the programming on which nodes we are giving the cluster head. So now we go to the other part of the result. These are also, I have shown the packet and event trace. You can just open it, have the packet trace information for each and every packet. Okay, one by one we can analyze the packets where it is moving. Okay, we can use some tools of packet or these Excel files of freezing and filtering the packets. Likewise, we have event trace. Having information according to the events. So now I was talking about the LEACH code implementation. So for LEACH code, we have some ready-made codes we have. So we have to just click on this netsim.sln solution file, and this LEACH code will open in Visual Studio environment. So I have already opened it. Here we will see the 2 protocols. One is having DSR and ZigBee protocol. So I've just opened this leach.c file where we have to define the cluster. So number of clusters are given there, and 4-5 types we have given. So we have defined these 4 nodes as cluster. We are using 64 node sensors. So we are giving 19, 22, and 43 and 46 as cluster heads. So we have enabled this code in leach.c. Okay. So we just have to build that code. Just right click on DSR and build it. Then right click on ZigBee and build it. So after building these codes, in our LEACH folder, we have a DLL. In DLL folder, libdsr.dll and libzigbee.dll. These 2 DLL files will create. So we will copy these two DLL files in our original DLL extension folder, that is in C, program files, NetSim standard. Here we have bin folder, which is having all the protocols implemented in NetSim in the DLL binaries. So here we have to change for DSR. So currently we are having this DSR, we just and we have renamed this DSR default so that our original DLL would not affect it. And we have lib Zigbee also, so we have to just rename it our original DLL. Okay. So we now copy those DLL. So now we have copied lib zigbee.dll and lib.dll. So when now one work on this wireless sensor network, we will have our edited DLL that will work. So now we'll just close this and open the scenario that is having the LEACH. We have ready-made scenario given here. So we are having these 64 sensors, 3 agents and 1 sync node. So we have defined some cluster heads in between them in the programming section. So our simulation will work accordingly. So we just run the simulation. So we can go to this packet animation and we click on run and see our data would be transferred through the cluster heads we have defined. So we have to increase the animation to see. So that's how we can implement a LEACH code implementation in wireless sensor network, or we can implement any other protocol by just stop this. We have this NetSim standard directory here. In SRC folder, we have a simulation folder. So when we open this netsim.sln, just close it. NetSim.sln file. So all the protocol available in NetSim would be open in the Visual Studio, so that we can change anything in the protocol. Okay, all the protocols are available here. Aloha, LODV, ARP, cellular, cognitive radio, DSR. So we have to just open that code and we can change anything in the protocols. Or we are making our own protocol, we have to save it in DLL extension and we can use it. So this is the way how we can change in the existing protocol. Now we will go to the IoT part. So IoT is Internet of Things. That is the history given there here. So it integrates all kind of sensing, identification of communication, networking, and informatic devices and systems that connects all the people and things upon interest. So that can be easily understood by this screenshot, this slide. That is very common. Most of you have seen this. This is a vision of IoT, where all the devices communicate among them. This key, this dog, this tap, all these devices would communicate through this IoT. All would be having some sensing devices, some communicating devices. This for patient monitoring, and this is for agriculture. So all these things have the IoT in vision, and some of the things have been implemented and some of the things are in the pipeline. So that can be implemented in IoT. So these are the application domain: smart and green buildings, the structure, energy and environment, then network healthcare, that is patient monitoring, and wearable health monitors and implantable devices that can be implant in the human body, that can senses the patient condition and give the data to a central location. Then smart cities, their transportation, pollution, water distribution, and in agriculture, I've seen in the slide. Then forest and wildlife application, that I've given the example of the forest fire. That IoT technology is having 802.15.4, and it works on 6 low PAN. Low PAN is low power wireless personal area network, and 6 is for, it works on IPv6, so it is 6 low PAN gateway given there. So in IoT, when we use the wireless sensor network, the sync node is replaced by the 6 low PAN gateway. So that gets all the data through the 6 low PAN gateway through the sensor, and it then locate the data to a centrally located host or a cloud-based solution. So this network protocol stack. This is the application layers, and the layer information is given there, where sensor receives the information, give to the 6 low PAN gateway, and is centrally located to host or any other internet cloud-based solution. And these are the research areas in IoT that researchers use these topics to analyze. One of the implementation I've shown you, that LEACH implementation. So now we will have some one example of IoT also. How I will design it for. We have to select IoT. We have to select the grid length, side length, and the sensor placement. So we are just taking 16 sensors. So click on OK. So 16 sensor would be placed here. Here we can see in the IoT we are given with the Internetworks features also, so that we can connect these host devices to switch and router, and we can connect the access point and connect the wireless devices also. So let's connect some routers here. First, a low PAN gateway. An agent is not required in this. So we connect it through a router. Then we connect a switch. Then it further can be connected through a wired device, wired node. Okay. If you want to connect a wireless node, you just have to select the access point, and you can connect it through router, and further the wireless node devices can be connected. So we just have to connect the devices through wired link. And this access point can be connected through router, and wireless node is connected through a wireless link. So here we use the application where we have to define the sensor application, from where we want to send the sensor application to which location. So let's say for sensor 6 we are transferring to this host 20. So sensor 6 to destination 20. So this sensor application has been added with the value of 50 byte. Distribution is constant, interarrival time is constant, and the value of interarrival time is given here by default. Or you want to send some data from sensors to the wireless node, you can select it, let's say for from 10 to 22. So we select 10 here and destination ID 22. We have to select another application. So we just select it for 6 and 20. This is saved. Now we have to add one more application, and we can select it from, let's say, 10 to 22. Okay, so we added two applications. Now you can see this 10 sensor will send the data to 22, and the 6 sensor will send the data to 20. So using this low-pan gateway, they send the data to the low-pan gateway, it senses the data and send it to the router. Router then further send it to the wire node and wireless node. So this is the combination of Internetwork and wireless sensor network that we have made. So we can run this simulation. First we have to change that bin folder, because we have added this for LEACH code implementation. So we have to just delete this libbsr.dll and rename our default DLL just to have our default DLL. Save. There is also lib zigbee, we have also deleted, and we have to rename the zigbee. Okay. So now our default libwizard.dll would work. So now we run the simulation. So here overall detail is given there about the networks, that these are common matrices we have. So these are having the wireless sensor, wireless LAN matrices, and these sensor matrices. This is power model matrix of transmission energy, receive energy, idle energy, sleep energy, and total energy consumed. Okay. So we can see its animation, how the sensor would send the packets to this wired node device and wireless node devices. So we can see here. So this is how we can implement IoT in this. If you want to change anything, you can change it in the protocol in Visual Studio. This NetSim Analytics have shown you for comparing different matrices of single technology. Let's say for wireless sensor network, we are comparing these matrices. So these matrix files are the result file that we have in so we just take more than 3 matrices for wireless sensor network. So we have taken these 4 matrices of the same network of wireless sensor, and we compare these matrices according to these parameters like simulation timing, packet transmitted, packet errored, packet collided, then bytes transmitted, payload transmitted, overhead transmitted. So this is the tool given for the comparison of matrices for different parameters in one application. Also, we have shown you this programming portion of how we can see some application of the protocols, cryptography, ARP, correcting code, detecting codes, framing sequence, okay, leaky bucket algorithm, shortest path. So if we select any of these programming portion, so we have a sample programming, or we can choose the user option. So in sample programming, the backend programming is running, and if you choose the user, you have to define the program that can be edited in the Visual Studio itself. So let's say we define its algorithm, either it is link state or Floyd. So we just select link state, number of routers, let's say 4. So in the GUI you will get the 4 routers. We have to define the distance between them. Source router, let's say, is 3, destination router is 1. So when we run it, it will show us the shortest path by running the sample program in the backend. So it is calculating the shortest path. So 3 to 1, the shortest path is 44, so it has defined. So its sample programming can be seen in by clicking this interface source code, and it can be open in this Visual Studio. You can see this link state algorithm. You can change anything in this programming. That you have to save in exe format, because in GUI when you select this user, it will ask you exe file. So that file you have to save in exe format. When you select it and run it, it will run according to your code. And you can study about this concept, algorithms, pseudocodes, flowcharts, about the program you have selected. There for study purpose. And all the manuals are given there, user manual, source code help, experimental manual, all these things are given there. So I've done with my presentation. If you have any query, you can ask me by writing it in the question box.